Hello, welcome to Miss Penn's online class. Today's date is Tuesday, March 31st, 2020. I've had some questions from students regarding the packet, so I figured that I would go over a couple things and do a couple examples for the first 6 sections of the packet. So I will give examples, and if these are still not clear to you, feel free to reach out to me, give me a call or send me a text, and I will get back with you as soon as possible. Hope you guys are having so much fun at home. Being out of school, of course, it is, we're quarantined and staying inside, but make the best of it. Okay, so first things first, we're going to start with section 12.6, which is improper fractions to mixed numbers. So I'm going to show you how to change an improper fraction to a mixed number. So the example that I'm using is example number 5 on topic 12.6. So if my fraction is 13/12 or 13 divided by 12, I will first start by dividing my denominator into my numerator. And if you can't do this in your head, all you have to do is do a division problem, which looks like this. So 13 divided by 12. 12, I can pull one set of 12 out of 13. And then I multiply. 1 times 12 is 12. Subtract. And since I have nothing to bring down at this point, then I could go ahead and write my answer as a mixed number, which we take this over here. The number here, my whole number, is my quotient. So this is the whole number. This is my numerator. My remainder is my numerator. And then my divisor is my denominator. So as long as you're doing your division correctly, then there should be no issue there. So you'll see how I have 1 as a whole number, 1 as a numerator, and I count my denominator as 12 here. Okay? Next, I'm going to show you how to change mixed numbers to improper fractions. And the example that I'm using for this one is number 1 on 12.6. So if I start with the mixed number of 2 and 1/3, the steps for doing this is to multiply your denominator, which is just 3, times your whole number, which is 2, and you put that number in your head. So 3 times 2 is equal to 6. Then you add your numerator to the number you already have in your head, which is 6. 6 plus 1 is 7. And then you keep the same denominator. So it ends up being 3 times 2, which is 6, plus 1, 7, and you keep it over the same denominator. Okay? Pretty straightforward. I know I move a little fast here, but I want to keep going, make sure that I cover everything that I want to cover, and I didn't want to hold you for a long time. So the next section that we're going to talk about is 13.2, which is the following page in the packet, and it is entitled Multiplying a Fraction by a Whole Number, and we're going to be using models. So what I did was I did example number 1 for this one, and I drew exactly what is on your page in your packet so you can see exactly where I'm getting these numbers from. So this is the model of a number of 1/3. So when we look at unit fractions always show us one piece of the whole, which the whole would be 3 pieces. So the unit fraction would equal one of those pieces. So my unit fraction in this case would be 1/3 because all of my fractions are 1/3. So then it asks the number of unit fractions. Well, all you have to do there is count how many unit fractions are in the model. And I counted 1, 2, 3, 4, 5, 6, 7, 8. So I'll put 8 here on that line. Then it says to write a multiplication equation. So all you do is take the number of unit fractions you had, multiply that times the unit fraction to get your answer. Now, the tricky part about this is what I don't want you to do. I don't want you to multiply the 8, which is your whole number, times the numerator and the denominator. You're only multiplying this whole number times the numerator and then putting it over the same denominator. So I have 8 times 1/3, which if I multiply my whole number by 1, which is the numerator, 8 times 1 is 8, and I keep my same denominator. So when I'm looking at this, it's saying I should have 8/3. And I do. 1, 2, 3, 4, 5, 6, 7, 8/3. Okay? Moving right on. The next section that I'm going to cover is going to be 13.3, which is multiplying a fraction by a whole number using symbols. So I'm using example number 1, and that example says 2/3 plus 2/3 plus 2/3 plus 2/3 equals 4 times 2/3, because I have 4 2/3 fractions. So I'm trying to figure out how many what's my fraction going to be equal to. So I take my equation, 4 times 2/3, and I brought it down here so that you can see where I'm getting everything from. So the first step that you do is you take your whole number and you put that whole number over 1 to make it a fraction, which is what I did here. So I took my whole number 4 and then I made it into a fraction by putting 4 over 1. Then you continue on by multiplying it times the fraction that is given. So I have 4 over 1 times 2/3. And then from that point, you just multiply straight across, numerator times numerator to get your new numerator. And denominator times denominator to get your new denominator. 4 times 2 is 8. And 1 times 3 is 3. And that problem is finished. So you just have to remember that you have to put the whole number over 1 to make it a fraction so that you can, it'll be easier for you to multiply. And then multiply it times the fraction that's already there. Multiplying your numerator times your numerator and your denominator times your denominator. Okay? All right. Moving right along. All right. The next section that we're going to do is going to be, just give me a second. I would like to move this back so you can see it a little better. Okay. The next section that we're going to cover is 13.9, using money to understand decimals. So the example that I used for this one is example number 1, which tells you that we have an amount of $3.52. And it wants you to give the dollars, the coins, and the dollars that you use in order to get this amount. And considering that they've already given you the denominations of the money that you're using, it should make it very easy. So they told you that it's going to be dollars, dimes, and pennies. So we already know by looking at this that $3.52. Remembering that we only use the word "and" when we are talking about a decimal, when we're dealing with parts or fractions. So this would be read as $3.52. So breaking it down using money, I have $3. I would need 5 dimes, which would be 5 times 10, which is equal to 50. And then I'll have 2 pennies to finish off my $3.52. So it's just a matter of making sure that you know the denominations of the money, which a quarter is worth 25 cents. A dime is worth 10 cents. A nickel is worth 5 cents. And a penny is worth 1 cent. Okay? Going along with that, I'm going to skip this one. I'm going to finish up 13.9, and I'm going to go to 15.1 first, and then I'll go back to the next one that involves money as well. So, 15.1 is solving perimeter and area problems. Okay, so With solving area and perimeter, you have to be very careful because they both have different methods of finding the answer. So for perimeter, all you do is take whatever shape it is, however many sides it has, and you're going to add all the sides together and get your unit. So say for instance, I had a rectangle and I had 4 centimeters and 4 centimeters here and 3 centimeters and 3 centimeters. So I have 4 centimeters, 4 centimeters, 3 and 3. In this case, I would just add all 4 of these up, and that would give me 4 plus 3 plus 4 plus 3, which is equal to 14, and then I have to write the unit. The unit here is centimeters. So in this case, my answer would be 14 centimeters for this example. Okay? So all it is a matter of adding up all of the sides and making sure that you put that unit to show that you are doing perimeter. Okay? The next part is area. And this one is a little tricky, so you have to be very careful. When you're finding area, you look at 2 sides. So you're going to be multiplying 2 sides in order to find the area, which is the space. So example would be the carpet or the ceiling. The perimeter would be thought of as the fence. If you were thinking about outside in a yard, you would think about the fence, not what's inside of the fence, but the actual fence or the border. For area, you're talking about the space that is taken up, okay? Or the area that's taken up. So when you find the area, you're going to multiply your length times your width, which basically what length and width is one side times another side. So you don't want to choose sides that are across from each other because those would normally, in a normal shape, it will be the same, such as this one. So you would take one side and then take a side that is perpendicular or joins with that. So for this particular problem, we're doing example number 1 on 15.1. And the example says we have the area here of this rectangle, and it says the area is equal to 63 square feet. And then I have a side length of 7 feet. So in this case, we wouldn't be doing length times width. We would actually be doing area divided by one of the sides, whichever side that you have. And in this case, we have the width, which is 7 feet. So if you follow along with me, you basically just multiply one side times the other. If you follow along, the area we already know because they've told us here. And we know that that's the area because anytime you're doing area and perimeter, you have to have a unit. If it does not say centimeters or kilograms or whatever the case may be, then you would just put unit. So notice here for my perimeter, I only have a number and a unit. But for area, I have a number, a unit, and it's saying that it's square. So you could read this as 63 square feet, or we could have also seen it as 63 feet squared with a little 2 exponent here. So you can see it either way, but either way, as long as you know that when you do area, you have to have the number, the unit, and you have to have square. This tells me that this is an area as opposed to perimeter. So they told us we had 63 square feet as our area. So A equals 63 square feet. And W, which is a width, or one side, is equal to 7 feet because it's already listed here. So if I'm looking at my original formula, which says area is equal to length times width, I'll just fill in the numbers that I have and we put in the missing numbers and you figure it out from there. So if we're multiplying to get an answer and we can't multiply, the opposite of that would be division. So we would do the opposite in order to find the missing part. So we know area is equal to 63 square feet. And all I'm doing is plugging in these numbers for the pieces. 63 square feet is equal to length, which we don't know what the length is yet, times 7. So then we have L, which is, we don't know what L is, but we got to figure it out. It's an unknown. So this is one of the times that it's sort of like using variables where we're putting in a letter to represent a number until we figure out what that number is. So L would be equal to 63 divided by 7. And if you know your multiplication facts or your division facts, you'll be able to tell that easily. 63 divided by 7 is equal to 9. So that tells me that my length here would be 9 feet. So sometimes we have to work backwards to figure out the answer. So same thing for perimeter. So if they're giving you the perimeter and they're giving you a side, you can figure out what the other sides are, because remember with perimeter, usually if it's a normal shape, it's going to have the same side across from each other on both sides. So you could just add those numbers together. Okay? And then the last thing for today, we're going to talk about section 15.3, which is solving problems involving money. Now, I'm using example number 1 as well for this one on that page. And it says, and I'll read it so you won't be wondering where I got the information from. So for number 1, it says, list the coins and bills you would use to make the amount of change for each situation. Then tell the amount of change. So make sure on all of your problems that you're doing in this packet that you are showing your work and you're actually following the directions and doing every part of the directions. Because remember, on the state test, you have to do all parts of the directions. If you don't follow the directions and you do something other than that, then of course they're going to count your problem wrong. So just make sure that you are paying attention to that and doing all the parts of the directions. So for number 1, it says Bryce bought a map that cost $7.35. He used a $10 bill to pay for the map. What is his change? So I just did a simple subtraction problem because we're trying to find out how much change you would get after buying this map. So we start with $10 minus $7.35. But if you notice, I have a bunch of zeros here that I cannot take 5 from 0, 3 from 0, 7 from 0, because we don't subtract that way. We subtract 0 minus 5, and since if I have nothing, I can't take 5 from that. So I will have to go and regroup or borrow. But regroup is the official technical term, so make sure you use that. And I just did simple regrouping. So I went over to this 0, couldn't borrow. Went over to this 0, couldn't borrow. And I went to this 1. I had 1 here, so I took 1 here, took 1 away, and then everything else became a 9. And then the last 0 became 10, so then I can go ahead and do my subtraction. So I came up with $2.65 after doing the subtraction. And now I have to write what coins and bills or dollar bills that I use in order to get this change. So I know that I have $2 here, because remember we read this as $2.65. So if you're listening to what you're saying, it should be kind of easy to figure it out as well. So $2, so I know I have $2 bills, plus 65 cents. The quickest way for me to get to 65 would be to have 2 quarters, which quarters are worth 25 cents. So 2 quarters would be 50 cents. So I have $2 plus 2 quarters, and then I need 15 more cents to make 65, so I need to have a dime and a nickel. So then I go down here and I want to add that together because I want to make sure that I have all of the correct pieces. So I have $2 plus 50 cents plus 10 cents plus 5 cents. And if you're worried about whether or not you did this part correctly, all you have to do is go back and take what you got at the end, $2.65. And since we were subtracting first, to undo that, we're going to do addition. So we're just going to add this $7.35 back to it, and we should come up with $10. Let's see what happens. Okay, so I have 5 plus 5, which is 10. Regroup my 1, 6, 7, 8, 9, 10. Put my 0. Regroup my 1. Notice that I keep my decimals lined up at all times. And then I have 7 plus 2, which is 9, plus 1. And we're back to $10. So if you're still having any problems from any of the problems that I've done today, then you have no problem calling me, texting me, whatever you need to do. Try to get in touch with me. But I want to make sure that you guys are doing the packets because they will be graded and this will count as your grade for this quarter. So you need to make sure that you guys are doing these. Don't take this as a chance to say, oh, well, it's a packet. They're not going to do anything with it. Please make sure that you know that you've done your packet. You've covered everything because all of this will be graded. So I can't deal with accept the fact, oh, I lost it, or I just didn't do it and have time, because we have nothing but time. So if you have questions, give me a call. Hope you're having fun. Hope to see for you guys. Hope you guys are doing well with your packets. Miss you guys. Have a great day. Bye.